Welcome to solverfy.
This question is pretty straightforward and just deals with calculating formula or molar masses of compounds. And so we're going to need to utilize our handy dandy periodic table to do that. And we're going to find that in the first example here for nitric acid, we can see we have one hydrogen atom, one nitrogen atom, and three oxygen atoms that make up this entire molecule. So we need to add the individual molar masses for each of the atoms here to determine the overall formula or molar mass for this compound. And so we find the atomic mass or molar mass of hydrogen, as I've circled here just below the elemental symbol on the periodic table, and that's 1.01 grams per mole. Do the same thing for the nitrogen, that's 14.01 grams per mole. And oxygen is going to be 16 grams per mole. But we can see in the formula that we have three oxygens, so we need to multiply that number by 3. We're going to add all of these up, and that's going to give us our overall formula mass for the compound. So for nitric acid, that's going to be 63.02 grams per mole. And generally speaking, reporting molar mass to the hundredths place in terms of accuracy, unless you're told otherwise, is a pretty good rule of thumb to follow. We'll do the same thing with the potassium permanganate here. So looking up potassium, we find that it's 39.10 grams per mole. For manganese, in the center of the periodic table, that's going to be 54.94. And then again, notice we have multiple oxygens, 4 of them in the formula. So we need to take that 16 grams per mole and multiply it by 4. So let's crunch some numbers here and figure out um, what the overall molar mass is for potassium permanganate. And so when we add up each of the individual molar masses, we get an overall molar mass for potassium permanganate at 158.04 grams per mole. Now in the next example, the calcium phosphate gets a little trickier because we have a whole polyatomic ion that's going to be doubled according to the formula. But let's start with the calcium. So you have 3 calciums, each of which is, according to the periodic table, 40.10 grams per mole, but we'll multiply that by 3 according to the formula. And now we're going to take this whole phosphate polyatomic ion and first determine the molar mass of it. So the phosphorus is 30.97, and we have 4 oxygens in the formula. And we know oxygen is 16 grams per mole, but we'll multiply that by 4. Now this entire mass that's in the brackets here has to be doubled according to the formula. And so that is going to give us, when we add up all of these numbers, the overall formula mass for calcium phosphate. So let's crunch some more numbers here. So I've kind of broken this down into parts. So when we calculate the mass of all 3 of those calciums, multiplying the 40 times 3, essentially we get 120.30. And we multiply all the components of the phosphate ion by 2, we end up with 189.94. We add both of those numbers together, and the overall formula mass then for calcium phosphate is a pretty bulky 310.24 grams per mole. Silicon dioxide is going to look real simple after doing the calcium phosphate example. So we've got 1 silicon, and according to the table, that's going to be a 28.09 grams per mole. And the 2 oxygens, which we know are 16 grams per mole, we'll put together here, and then silicon dioxide, we'll crunch some more numbers and figure out that total molar mass for it. So when we add up the oxygen and silicon contributions for silicon dioxide, we end up getting a molar mass or formula mass of 60.09 grams per mole. Now there are a few other examples we're going to look at, but I'm going to switch to a different page and we'll take a look at the additional examples. So the next example we're given gives us a sample by name. It's gallium sulfide. And so in order to find the proper formula, we need to utilize, again, our handy dandy periodic table. So we notice gallium here is in the group 3 of the periodic table. And most of the time, group 3 um, metals like aluminum, gallium, indium, and so on will take on a +3 charge to match their group number. So we're going to assume here a +3 charge for the gallium. The sulfide is located in group 6, and most of the time those elements in the oxygen family will have a -2 charge. So we just need to make sure our charges balance here. That's going to require 2 galliums, give a +6 charge to the compound. 3 sulfurs is going to give us a -6 charge overall. So our charges will balance and we'll have a 2 gallium, 3 sulfurs to accommodate for in the gallium sulfide um, overall formula. So we look up the molar masses for gallium. That's 69.72. We're going to require 2 of those. 3 sulfurs, each of which have a 32.07 molar mass. We crunch the numbers. I've sort of, again, broken them down individually. We get an overall formula mass for gallium sulfide at 235.65 grams per mole. The next compound is chromium 3 sulfate. That's what they tell us. So first thing we need to know is the formula for sulfate and its charge. So that's an SO4 2 minus. Chromium 3, when they give you a number in parentheses for a transition metal like chromium here, the 3 in Roman numerals represents the charge on that transition metal. So chromium 3 is a 3 plus charge. So it's going to look just like the formula above. We have a +3 metal, a -2 overall anion here, and it's going to require 2 chromiums and 3 sulfate ions to have a charge balance overall for chromium 3 sulfate. And so we're going to plug in here the um, individual molar masses for each of these atoms and crunch some numbers as we did in the previous example. So the final example here tells us we have a phosphorus trichloride. So this is the formula we're going to have. Phosphorus is 30.97. We just have one of those. Each of the chlorines is 35.45, but we have to multiply that by 3 in the formula. And if we, again, kind of break down the numbers here um, into the 3 chlorines, the 1 phosphorus, overall the formula mass, we crunch all the numbers and add them together as a 137.32 grams per mole for the phosphorus trichloride.